In this video, we're going to define statistical significance, p-values, and the critical values of a test statistic. We conduct a test under the assumption that the null hypothesis is correct, and we endeavor to see if there's an acceptable level of probability to reject it. So, strictly speaking, if we don't find evidence to reject the null hypothesis, we can't say that we accept the null. The aim of the hypothesis testing is not to verify the null hypothesis, but rather to examine or to test some claim or condition delineated through the alternative hypothesis. So to conclude whether there's a difference between the two sample means requires a p-value. There's usually some confusion about the precise meaning of a p-value. The difference between the statistic computed in the sample and the parameter specified by the null hypothesis is computed, and the probability of obtaining a difference this large or larger is calculated. This probability value is a probability of obtaining data as extreme or more extreme than the current data. It's not the probability of the null hypothesis itself, as people commonly say. For instance, if the p-value is 0.005, this does not mean that the probability that the null hypothesis is true is 0.005. It means that the probability of obtaining data as different or more different from the null hypothesis as those used in this experiment or calculated through these samples is 0.005. So it appears as if the probability of the null itself is the definition of the p-value. It's very similar, but it's slightly different than what the real definition is. So the p-value doesn't tell you if the null hypothesis is true or false. It just tells you how likely it would be to obtain a specific result, like the one you estimated from sample data, if the null hypothesis were true. So the p-value is a piece of evidence that we use in a statistical test, but it's not definitive proof. Now, critical value is a statistic. It's used in hypothesis testing. It's a boundary that separates the rejection region from the non-rejection region in a hypothesis test. So we can use that to determine if a result is statistically significant. It's like a different method. It's a specific threshold that we use to decide whether to reject the null hypothesis or fail to reject the null hypothesis. Critical values are determined by the significance level, alpha, which is the probability of a type 1 error, or incorrectly rejecting a true null hypothesis.